Okay, in this video we're going to talk about, we talked about kind of the internet as a whole and how it goes through these series of routers. We talked about kind of how the path it goes inside of the network typically. In this video we're going to talk about, okay, I know the path that it gets to there, but how does it know where to go? How does it know when I type llbean.com in my web browser, how does it know to get over to this server that's located in Maine and through these routers? Well, the first thing that we have to talk about is each of our systems that are connected to the internet. Sometimes we call those nodes. So anything connected to the network is called a node. So each of these computers here connected are a node on the network. So basically anything plugged into a port on a switch is considered a node. Okay, so every node on the internet, everything that requires access to the network, requires its own unique, what we call an IP address. An IP address. And I'm having this problem again. IP address. Why is this erasing? Okay, so an IP address on every node on our network is a unique number that allows it to function on the internet. So basically, anytime we're accessing the internet out here, our computer is identified by a unique number. A unique number. It's kind of like a telephone, right? Or an address of your house. So I'm the only person in the world that lives at 3216 Bach Avenue, or me and my family does, in Cincinnati, Ohio, right? It's a unique address kind of on the map, right? And same with my phone number. Nobody else has my phone number in the world. Okay, so it's unique to my phone. So if you're working on the internet, every device, every node has to have its own unique number or IP address. And we can find out what our IP address is on our client. So if we're on a Windows computer, we can run what's called ipconfig. So IP stands for Internet Protocol, and the number is an IP address, Internet Protocol address. So if I run an ipconfig on a Windows machine, and I actually have several connections here. Look at the first one. So the IP address of my computer is 198.168.2.23. 198.168.2.23, and that's actually a local address. I probably have a different IP address I'm using for the outside, and we'll talk about that a little bit later. And notice a couple other things here. We have this default gateway. That's the IP address of the router that my system is accessing when it wants to go out and use the internet. Okay, so we have these unique IP addresses, and www.llbean.com has an IP address as well. So we can actually see what our real internet address is. If we go out onto the web, there's a couple other of websites, kind of like what is my IP. So my IP address that I'm using out on the live internet right now is 129.137.168.18. So that identifies me specifically. And I can do an IP lookup and find out what llbean is using. Well, that's going to domain lookup. Here we go. Alright, so the IP address for www.llbean.com is 216.151.48.23. So I can actually get to the website probably by going to that address as well. And it looks like it is an LL Bean website, but it's a different one. It's not recognizing. This is just something else going on. But this is the same server as the www.llbean.com. It's the same server. Okay, so we have these unique IP addresses. But again, when I go to LL Bean's web server, when I want to access it, I don't have to type in that IP address, right? So luckily for us, we humans like names rather than numbers. So I don't often remember the phone number of, say, a friend of mine who lives in Virginia. So I have her phone number in my phone just by her name. It's a similar type of thing on the internet. So we remember names like www.llbean.com, and we can then use that to access the IP address. And how we do that is we have within our networks, we have what's called a DNS server. A DNS server. And so here off of my core probably, I have this server, a DNS server at UC. And so what's happening here is my client computer, to find out how to get to www.llbean.com, the computer doesn't know that internally. Computer wants an IP address to access. And so what it does is my computer here, my client, says when I plug in I want to go to www.llbean.com, the first thing it does is there is a local file called a hosts file that it'll look to, and it'll say, hey, do you know where www.llbean.com is? And most of the time it's not in this local file. And so if it's not there, it goes to the DNS server that's in my network that's plugged in. And so it goes over here to this server, and the computer says, hey, my user wants to go to www.llbean.com. Do you know what the IP address of that server is? And if it does, if it has it in its memory or in its files, it'll tell my client what the IP address is. And then my client will use that IP address to kind of tell the routers where I want to go to llbean.com. So once my computer has that IP address of www.llbean.com, what it does is it says, I want to send this information to this IP address because my client now knows the IP address. It was 216 dot something, right? And it tells my router here, hey, I want to send this information. I want to request a connection to this 216 address. My router then knows kind of where that is on the network and can figure out what route to send the information to get to llbean's web server. Okay, and when it gets there, it can then communicate. And now at this point, my client and the server are communicating using IP addresses rather than what we call fully qualified domain names. Okay, and so what happens if my UC network doesn't have that llbean IP address in its server? Well, it's kind of a little bit trickier. So the internet, in addition to having all of these routers in place, also has a series of DNS servers that are housed on a number of these ISPs. So like I said before, UC has its own DNS server, right? So UC has its own DNS server, right? And for sure, UC's DNS server knows everything about all the clients within UC. So if somebody wanted to go to www.uc.com, UC's DNS server would know how to find it. But a lot of these ISPs also have, or probably all of them have DNS servers, right? Attached to them. So all these all these ISPs have their own DNS server. llbean.com has its own DNS server. And so what happens is we don't have to manually add all of the internet's domains or computers or websites into our UC DNS server. What happens if there's a new website out there? So let's talk about, I don't know, mas.com. That's my initials. So let's say I start a new website, right? And I connect it to this ISP. Okay, so I've got a DNS server here which says, hey, www.mas.com, this is the IP address. And so what happens is, let's say my client now wants to access www.mas.com. It's a new website, and so UC's DNS server doesn't have that stored locally. And so what happens is UC's DNS server asks my ISP or Net's DNS server, hey, this guy's looking for www.mas.com. Do you see it? Do you have it? And it'll say no, and it basically goes through these connections of all these different DNS servers until it finds the mas.com DNS server, because my ISP knows where that is, and it says here's the IP address. As that address then gets filtered back through those DNS servers, they keep a copy of that back to the UC server, and then my client gets the IP address of www.mas.com. Then the next person within UC who would ask for it, UC's DNS server would then have a copy the next time it goes through. And so we have, in addition to having these IP addresses, again, we like names, and so we utilize these DNS's servers to do that translation for us between name and address. And again, all of our networks, our ISPs are going to have domain name servers, etc. So backing up a little bit, these IP addresses, everybody has to have an IP address to work on the network. So where do they come from? How are they assigned? Well, there's a couple things couple ways we can do that. So if we go back up into our UC network, we can manually plug in the IP addresses to our client machines when we set them up, right? But that's kind of difficult to do. And so what most networks do, and probably your home-based network does as well, is we, in addition to having a DNS server in our core, we also have a DHCP server. And what that does is divvies out IP addresses. So when my computer boots up, it says, hey, I want to participate on the network, and UC's DHCP server gives me a valid IP address to communicate on the network. Okay, but as we saw before, my IP address internally was different than the one it showed I was using on the live internet. So we're going to have one IP address that we use just within our own network generally, and that was the 10 dot address. But then once our traffic goes out through our router here, it does a translation to give us a public IP address that we can use on the internet. And that allows us to share fewer public IP addresses. It allows for some security within our networks, etc. Most of our servers, on the other hand, do not use DHCP. They use a static IP address, and that's because so we don't have to update our DNS server quite as often for those servers that are being accessed quite a bit.